Will now be
Okay,
recorded.
there she is. Okay. Welcome, everybody. My name is Dr. Mary Beth Neely. I am the scientific coordinator for GeoAqua Watch, and we're delighted to welcome you back to the second installment of our webinar series for the 2025-26 season. Our director, Gada El Srafe, is currently, unfortunately, with her daughter in the medical realm. So she unexpectedly could not join us today. So I'm happy to to welcome everybody. We are in our 11th year, and we try to feature any sort of information, project updates that would be of interest to the larger GeoAqua Watch community. We do have a repository of past webinars. I will provide those links in the chat. We will also have a moderated Q&A session with our speaker at the conclusion. And if you have any questions, you are also free to pop them in the chat as well, and we will moderate those at the end. We do just ask for you to please mute your phones or your microphones. And I am pleased to now introduce Dr. Lawrence Carvalho, who will introduce our speaker. Thank you.
Thanks, Mary Beth. Yeah, I'm going to keep this very brief, but I just want to introduce Eloisa Vargiu, who is the coordinator of the Ideation project that you see on the screen here, which is a Horizon Europe project in support of the Mission Ocean. And just to sort of say that Eloisa is also leads the sort of water and digital systems group in Water Europe as well. So you can maybe ask her questions about Water Europe as well. So Eloisa, I'm just going to hand over to you and let you present your talk.
Thank you very much, Lawrence. Thanks to the GeoAqua Watch coordinators to invite me to be here today. And thanks, Mary, because I will need your technical support during this presentation. So I'm Eloisa Vargiu. I work in Cetaqua Water Technology Center located in Barcelona. And here I have two roles. One is a senior researcher in the digital water sector. And is it for that I'm also leading the expert group in Water Europe. And on the other hand, I also a specialist in preparing European proposals. So I give support to all the team when a proposal is under our hands. And today I will give you an introductory view of the work we are doing in Ideation that is linked to the roadmap that will be given at the end of the project. And this roadmap will be to make possible the interconnection, the definition and development of interconnected digital twins for inland waters. So next slide, please. I organized the presentation in this way. First of all, I will give you an introduction, a very high-level introduction of the digital twin ocean, because it's where everything started. So it's just to put into the context why ideation comes here. And then I will show this link that we are doing between the ocean and the inland waters. That is part of the Ideation project, and I will present you the methodological framework we defined and we are developing to have this final roadmap at the end of the project. I will also show an example of future implementation, just to give you a better idea of what I'm talking about, because it's something that we all have during our meetings, because we want to concretize somehow what we are doing, and then some conclusions. Next slide, please. Okay, so first of all, we are talking about digital twins. Digital twins are virtual replica of the physical world. So in 2021, the European Commission launched the call for the definition of a digital twin ocean. That it means a virtual replica of the ocean. And they opened a call. The call was won by different projects, and now the initiative is undergoing, and they are started the phase 2 right now in April this year, and the third phase will start on 2020, final 27, beginning of 28. And the idea, so what the European Commission were asking for was to have this model of the ocean and all their components, its components. So it means that they are preparing an ecosystem where researchers, decision makers, marine experts, scientists may try different services and different functionalities linked to the ocean, and put everything together inside this ecosystem that is the digital twin ocean, and make research. Actually, there are several calls that are still open on this topic, because is an open topic that is very important, very relevant for the European Commission. And as I said, they are now in the phase 2, so there is also a platform that is available as a beta version, where scientists and researchers can make some tests and proof of concepts. Next slide, please. Okay, so this slide just show, I mean, summarize which are the benefits at the end of this virtual replica of the ocean, because marine and coastal policies may use it to test the effectiveness of planning infrastructure. Researchers may assess the impact of human activities and climate change. The blue economy stakeholders may ensure sustainability by reducing environmental pressures, and everybody, citizens and us, let's say, contribute to science and empower our citizens. So these are the benefits of the digital twin ocean, and all the calls that are launched by European Commission and all the tests and proof of concept that are now in the digital twin ocean are answering some specific questions. For example, those that are in the slide. I'm not going to read all of them, of course, but I mean, if you have as a researcher a very specific challenge, and you want to test and to have just a very simple service, you may test it now in the digital twin ocean. Next slide, please. And it is where the first video is. So Mary, please. This video is just to give you an overview of the work that they are doing in the digital twin ocean. If it's not working, we may skip it and give in the chat the link, and then after the webinar, you may see it. Probably it's easier in this moment.
I'm so sorry. Let me try it one more time. This was the digital twin of the ocean, is that correct?
Yes.
Okay. And are you seeing it on the screen?
Yeah, you will see YouTube. Yeah, the problem here, but
Which
no, you have to
are
go
these?
back because it's no, you have to go. Yeah, yeah, but the issue is here is that
Oceans cover over 70% of our planet.
I'm sorry, say that again.
sorry, that
It's the wrong video.
no, it's the right one, but it's the long version. But it is what it is. I mean,
I'm sorry. Are you able to hear the audio though?
no, because I cut in the presentation. But okay, let's go. It's 3 minutes of video. We can do it.
Sustaining vast and complex marine ecosystems and supporting billions of people. We need to know how our oceans are changing to protect and preserve them for future generations. The European Union, under its mission Restore Our Ocean and Waters, is developing a digital twin of the ocean, a digital replica, to help us understand and predict the impacts of human pressures and climate change. This powerful tool draws on Europe's advanced data resources, providing access to data from assets like the European Marine Observation and Data Network and Copernicus, the European Earth Observation Programme. The digital twin ocean feeds this data into state-of-the-art artificial intelligence and computer models to simulate oceans under different environmental scenarios, building a digital replica that illuminates our ocean's past, present, and future, and fosters new links between science, business, and society. Policymakers in European member states will have countless possibilities at their fingertips. They will be able to investigate specific what-if scenarios, identify environmental problems, and decide on the best course of action to mitigate harmful events such as pollution or provide risk assessment of coastal flooding. European researchers will also work together in a single digital environment, tackling issues such as the impact of ocean acidification on marine ecosystems and more. In this way, the digital twin ocean is revolutionizing science by bringing together previously separate research fields. This integration goes beyond sea and ocean data, combining atmospheric, geological, and population information to generate real-world practical applications. Imagine a coastal zone manager who, together with a blue energy business, wants to install new ocean wind farms. Using the digital twin ocean, they can use data on the ocean currents and wind patterns, as well as the shape of the ocean floor, to pinpoint the best locations for this new marine infrastructure. Or when setting up new aquaculture sites, the digital twin ocean can provide data on ocean currents, nutrient hotspots, and fish farm waste to find the right location for their farms. In these scenarios, it can even take into account the impacts of climate change, such as marine heat waves and altered wind patterns, to find the best locations over the long term. The EU's digital twin ocean is transforming ocean knowledge into practical benefits for all its citizens, strengthening its research, supporting a sustainable economy, and preserving the health of our shared ocean. Learn more about how the European digital twin ocean and the mission Restore Our Ocean and Waters can benefit you and our planet.
We did it. Thanks, Murray.
Okay, let me hop back to the PowerPoint.
Okay, thanks. So in the video, they explain the DTO initiatives that, as I said, starting in 2021. But some year after, then the European Commission decided to open to the rest of waters, not to inland waters. So not only concentrate of the ocean, but to build a replica, a virtual replica also of the inland waters, and where the Ideation project started. It was the only project founded under this call, and it is a coordination and support action. That it means that we are not going to develop the digital twin for inland waters, but we are preparing the road to do that, and we are putting the foundations for this future development of the digital twin for inland waters. And so in these slides, a part of the ocean that is covered by the DTO, I put also the type of waters of inland waters that we are considering in ideation: snow and ice, reservoir, lake, wetland, river and estuary, coastal water, groundwater, and urban water. So next slide, please. Another video. Sorry, Mary.
Bear with me again.
Starting as raindrops, they gather into rivers, travel to the coast, and finally reach the ocean. These are the inland waters, all connected, part of a continuous flow. They sustain life, power industry, and shape the environment we live in. To effectively manage these vital resources, particularly in the face of climate change and growing demand, we need smarter tools. Tools that can accurately translate the complexities of the real world into digital representations easier to be managed and shared. That's the power of digital twins. A digital twin is a dynamic virtual model that replicates real-world systems by integrating real-time and historical data to support operators in making more informed decisions. For inland waters, this means we can simulate conditions, monitor changes, predict impacts, and make better decisions. Ideation, a coordination and support action composed of an experienced consortium of 11 European partners and led by Cetaqua, is preparing the way for integrating inland waters into digital twin ocean ecosystem supported by the European Union, to create a unified digital representation of the entire hydrosphere. To truly understand and manage our inland waters, this project will prepare a common language, a framework for creating digital twins. These virtual representations will encompass the full spectrum: rivers and estuaries, lakes, wetlands, reservoirs, urban water, groundwater, snow, ice, and coastal waters. This framework will also incorporate the crucial interdependencies between these systems through the use of shared data and smart models. Collaboration is all the core of our work. Through multi-stakeholder forums based on water-oriented living labs and partner countries networks, Ideation engages experts, policymakers, researchers, and communities to co-design the way forward to future digital twins of inland waters. We are preparing an open knowledge inventory called Open Keywords and a robust reference architecture to ensure interoperability across systems and platforms. Thanks to Ideation, the future digital twin of inland waters will help, among others, to protect ecosystems and ensure sustainable access to freshwater resources, improve monitoring and sustainable use of inland water bodies, support informed, strategic actions through integrated digital insights. Our roadmap will lay out clear, strategic steps toward a future where inland waters are digitally connected, better understood, and more sustainably managed. Follow Ideation on LinkedIn and visit our website for more information and updates.
Thank you.
Bear with me just one moment again.
No problem. Okay, if you go to the, okay, perfect. So this slide just to summarize what is already said in the video. I want just only to point out that one of the requirements that the Euro Commission put in the call that they launched for this project was to be that the solution must be interoperable with the digital twin ocean. So we are working together, the digital ocean developers, to be sure that our solution is compliant with their solution, and to this vision to have a unique digital twin for hydrosphere, and at the end of all these phases of development that will be done in the future. Next slide, please. Okay, so it was also mentioned in the video that we are defining a methodological framework to define to define this roadmap to put the foundations of the future digital twin for inland waters. So we have this methodological framework that is composed of 5 steps. The first is the multi-stakeholder engagement. The second one is the development of a comprehensive review. Then there is a performance gap analysis that will help and will be used to define a reference architecture, and then everything will go in the final roadmap. And now I will go through the step by step. So next slide, thanks. Step 1, as I said, is about the engagement of stakeholders across multiple countries in Europe. And if you go into the next slide, there are some more details on that, because we perform a very huge work engaging stakeholders, and in 18 months we'd reached 500 stakeholders, and in 17 countries. Actually, we are going to have 18 countries, because we also engage another one. Latvia is also included now in our list. And we perform the work of engaging stakeholders by considering the water helix. And so we contacted academic and research representatives. We had some national, regional, and local governments and their organizations. We also contact people from the industry, and then we are trying, as you may see, the number is the one less representative, but we want also we are also trying to engage media, citizens, and culture sector representatives. And starting from this work, at the end, we defined, thanks to the first phase of the multi-stakeholder forum approach, we defined the functional and non-functional requirements. If you go to the next slides, I just put a few words regarding how we organize the multi-stakeholder engagement, that we divide in 2 phases. The first one was to let know to the stakeholders what Ideation was about, and to present the overall idea, and to define with all the stakeholders the list of type of water that they are more interested in, considering their geographical aspects. For that, we decide to follow a divide et impera approach. That means that we divide Europe in the different 17 regions, and in each region we performed a multi-stakeholder forum to select this type of waters. And also we discuss with the stakeholders the requirements, focusing on the generic view of digital twin for inland waters, but also of specific type of waters when our stakeholders had some clear idea of a specific application that they want to see in the near future. In the second phase, we focus on a specific type of water in each of the country. So we are still in this process. We have a lot of meeting scheduled, and some of them have been already done, but there are more. For example, on Friday we have one of them, and the goal in this case is to show to our stakeholders that could be the same of the first phase of they could be also new ones. In particular, we have new countries in the second phase, and we present the results of the project. So we present basically the reference architecture and the so-called open keywords that I will explain later in another slide. Okay, if you go to the next one, I put just as a result the some of the requirements, both non-functional and functional, that we had collected. As you may see, we divide them in categories, then in subcategories, and we ordered and we consider where in which countries they was required, because it is an important issue for us, because it is linked also to the corresponding type of water. If you go to the next slide, the second step of this methodological framework consists in the definition and development of a comprehensive inventory that we call the open keywords, because it's an open knowledge base for water systems. And this inventory is composed of 6 catalogs. One of them is about EU and international policies and standards for inland waters. Another one is regarding EU projects and information systems outputs. Another one is regarding scientific research results. Another one is regarding data models, AI technologies, simulations, intelligent systems, and digital twins related to water. Then we have a catalog on inland water open data and sensing source. And finally, a catalog on data and services from National Meteorological Organization. If you go to the next slide, I put the numbers that we have in the first version that was submitted last year after one year of project. And we collected 39 policies, 515 projects, 430 scientific results, 1,061 tools and technologies, 5 open data sources for Earth observation, and 50 meteorological databases. So what it wasn't expected, at least by me, when I prepared the proposal, because I was also involved in the preparation of the proposal in that time, was that having these very huge numbers. So we were thinking like a review in terms of a scientific paper collecting these 6 different types of information and data, but then we had this huge number. So now we are in the phase of thinking what to do with this, because I mean, if you are going to open an CSV file with 515 projects, I mean, you are not able to have the information that you may need. So we decide, and if you go to this next slide, to have like a chatbot specific for ideation for the open keywords. And this chatbot is like a ChatGPT, but specialized on the open keywords data that are collected there. And so you may ask to the tool for projects, for policies, for country in which type of water is more or less important. I mean, you may use it like a chatbot. What it is of course is a proof of concept, because it wasn't part of the project, but now it is, because we need it, and also we want to use all this huge amount of information that we have. Now, I wanted to have a demo, but I think that since I'm not um, managing the presentation by myself, I think it's better to skip. But if you are interested, I will. I mean, it will be a pleasure for me. In another occasion, you just write me an email, and we may have a separate meeting for that, because I don't know how to do this live demo now. So if you go to the next slide, please. We move to the third step, because what we have done, it was, as I said, with the stakeholders, with collect several requirements that we put together, we order in categories, and in the open keywords we have a very huge number of information and data, as I said. So now the issue is, okay, how we may put everything together, and we need also to check if there are some requirements that are not covered yet, but what is in the literature, or some others that already covered, and so in which project, for example, it is covered, and how may you use it. There is a tool that may perform this. So we did this gap analysis. Next slide, please. And also in this case, we were prepared for what we had, because, as I said, requirements are okay. I mean, as are a human document, so they are manageable, let's say. But in the case of the open keywords, we have too much information. So what we did is to use a large language model to put together all this information and to divide what we have in the two boxes, requirements and open keywords, a list of categories that are those that are there in the um, in the slide, and we did it automatically. And then we perform an analysis of the results to check for missing capabilities, underperformance, and lack of scalability. That is, of course, something that we want to guarantee to the final developer of the digital twin for inland waters. Next slide, please. Here I put some of the results that we have. Now next please, because more or less I said that. Okay, here we use these categories to categorize all the material that we have, both as requirements and into the open keywords. So we consider water supply, wastewater management system. We consider flood control and stormwater management systems, water quality monitoring control systems, water data and information systems, water conservation and efficiency systems, and irrigation and hydroelectric power generation systems. So, and this is the main results that we presented this year at the CCWI conference. We presented a paper with the first 3 steps of the methodological framework, and one of the main results was this one linked to this gap analysis. If you go to the next slide, we have here one of the main results that will be made available by the project. Another one, of course, is the open keywords. And the idea of the open keywords, as the name says, is to have an open tool that will be available. We have to check with the project officer and with the commission how to do that, but is our intention. And another relevant result is the reference architecture. If you go to the next slide, the reference architecture is to give the main modules and the main components that we think, according to our results, that are mandatories to define the future digital twin for inland waters. So we define it, and just we put this imaging as an example. Is not a real mock-up, is not neither a real digital twin, but we put to have an idea of what we are thinking to have in the future. Actually, now we are working on the more detailed mock-ups for a specific example that we want to use. in our meetings, and also to show to the project officer the work that has been done. If you go to the next slide, there is a sketch, the high level, the very high level sketch of the reference architecture, just to give you a view of what we are doing. Then, of course, I'm not going to do today, but you may go as a zoom in each of the boxes, and you will have all the modules that we defined and we think that they are of interest. And also, we will provide a technical core assessment of all these modules that we consider relevant, also to give for the future development some hints regarding the low cost, the life cost assessment and the life cycle costs of the solution. And so the main module of this reference architecture are the data layer, that is in charge of govern the acquisition, storage, standardization, and publication of data in an integrated manner. Then we have the digital twin core, that is the one that perform computational and local logical operations, and make it possible to use then the data through analysis or transformations. And a very relevant module, very important also because our goal is to have interoperability with the DTO, is the interoperability hub, that is like a collaborative environment for the management, creation, and validation of configuration files required to deploy services and process. So is an internal needs of interoperability, but is also the external one with other solutions, with other digital twins, and of course with the digital twins of Ocean. Then we have the part of the application that basically is the one that it is seen by the end user that may interact with the system. And finally, we have the cluster orchestrator, that is a dynamic and scalable cloud native ecosystem to support the entire architecture. And its goal is to ensure flexibility, isolation, reliability, high performance. So is a role really important for the overall reference architecture. So at the end of the project, this is the first version of the reference architecture. We are working on the second one, updating it, and also to be more compliant with the digital twin Ocean, and also with destination Heart, with Destiny. And yeah, at the end, we will present this to our project officer and thus to the European Commission, and it is one of our suggestions for the future development. In our opinion, the modules that are now in this picture are those that must be there in the digital twin, and then of course each of the boxes with differences and depending on the real use and the real application that the end user has in mind. If you go to the next slide, there is the final step of the methodological framework, that is the one that will give us the possibility to give as an open final results of the project, the final roadmap. If you go to the next slides, there is an animation. I hope it's working. Okay, so this roadmap will include, of course, all the requirements that come from the stakeholders. Click, please. The SWOT analysis of the overall work that we have done. Click. Okay, the reference architecture, of course. Click, sorry. Okay, the data sources that are included in the open keywords. Next, please. Okay, the interfaces for interoperability. Next. The technical recommendations, because we have to prepare at the end of the project also a list of recommendations. Then the guidelines for the interfaces to the DTO, and two more. the technical governance, and the last one is the assessment from a technological point of view, from a life cycle assessment, from a life cycle costing, and also from a socioeconomical point of view. That is something that we are also working in this second phase with our multi-stakeholders. Okay, I don't know if there are very a lot of questions. Otherwise, I want just to give you an idea, because everything is really abstract, and so during the project. From all the partners and from all the activities that and the task that we were performing, raise this need to have something more concrete to working with, just to understand what we are doing. And so we decided to have the so-called reference use cases. That it means that since we have no pilot, we are defining some kind of pilots, co-design actually, together with our stakeholders. So in Switzerland, we define the one for snow and ice, in Cyprus, the one for reservoir, in Greece, the one for rivers and estuaries, and also for wetlands, in the Netherlands, the one for groundwater, in UK, the one for coastal water, in Italy, the one for lakes, and in Spain, the one for urban water. If you go to the next slide, I just put as an example the one that we defined here. We co-define, as I said, because we cannot be expert of everything. So we decide to co-define these reference use cases together with the final users, so the stakeholders. And in each of the regions, we check and we contact some relevant expert in the field. So in the case of urban water, I mean, is our country, so it is in Spain, and we work. We in Cetaqua are part of Veolia, so we work with a lot of water utilities. So urban water was our water, and we decide to work in this co-definition with Aguas de Barcelona, that is the main water utility here in the Barcelona areas. And we identified first which are the end users, because otherwise it's also difficult for the stakeholder to understand which are their needs. So we define as end user the water utility manager, and starting from that, we start a discussion and brainstorming with them, with our colleagues from Aguas de Barcelona, and we identified three problems for this future digital twin that are related to water scarcity, low reservoir levels, and climate change impacts. And so we ask them, okay, considering that these are the main problems for you in this moment, if you have the possibility to have a wish list without thinking on the cost, without thinking on timing, or without thinking on sensor that you may need, which are the challenge that this digital twin should address. And there is the list here that is predict future water availability. So it's important, considering the water scarcity, to have this aspect, and also considering water scarcity and the low reservoir levels, the quality of water become more and more relevant for a water utility that wants to and must provide drinking water to their clients. Then they have also they are interested also in considering the cost assessment, advanced forecasting capabilities, that is of course linked to the climate change impacts. They want to have the possibility to integrate multiple data sources, that it could be in the same sector, so the water, but could be also to use other data, for example, that come from the energy sector. And then they want to have this digital twin to make a decision, to have a support in their decision. Of course, it's not substituting any human. And also, since in the open queue, as we are also collecting policies and directives, they also would like to have this future digital twin for checking regulatory compliance. And yeah, and here we put just a visual view of what we're talking about. So here it's just a sketch of the all the part that will be involved in this digital twin. So we have to, of course, considering the need of checking the climate change and also the problem related to water scarcity. Of course, we have to measure somehow the precipitations and also to consider the extraction from the groundwater. And since is a real water utilities, of course, we have the water treatment plant that is also part, is an actor, let's say, of this digital twin. The wastewater treatment plant is another one. The water reclamation plant is another. So we have to, one option that we had actually talking with our colleagues from the project, from Aguas de Barcelona, was that we may in principle have a different digital twin for each of these components. And so what we want to monitor is the overall cycle of the water, considering all these actors and considering that everything then is discharged in the Mediterranean Sea. And in the case of Barcelona, we have also raw water that comes from the Llobregat River.
Eloisa,
Okay.
I am mindful we have about 8 minutes left.
Yes,
Do you
yes,
want
yes.
to
I just
wrap
want to
up and we
say,
can do questions?
sure. I just want to say, I was checking the time. Thanks, Mary. Was just to mention that for each of the reference use cases, we also perform a SWOT analysis. This is a summary of what we did with Aguas de Barcelona, because we co-define with them. And for example, they are worried regarding the availability of the models or the future interoperability. They see as a threat, for example, but they see also several strengths and several opportunities. So they are interested, but I mean, depending of the end user that with which we co-define the reference use case, we had different worries. I mean, but all of them also highlights the strength and the opportunities that they see. Okay, there's last slide in the conclusion, but we may go directly to the. I mean, because I just summarized everything, so I prefer to go to the questions. Thanks.
Okay, I did see that there was one question in the chat from Marini. I'm just seeing it first, so I will ask that one first. Arini Politi asks, regarding stakeholder engagement, these 18 countries are only European. Do you also plan to engage with non-EU countries? And is the digital twin going to be applied globally or developed only for the EU region?
Okay, good question. The 18 countries are only European, and because because we work together with the European Digital Twin Ocean, that is also considering only Europe, and we are doing the same in this moment also in Ideation. I don't know if in the future we may open to other countries. Probably we will, but it's not part of the project. The project is focused only on European countries.
Okay, thank you. Does anybody else in the audience want to unmute and ask a question? I did put a question in the chat myself, but I'll give the opportunity to others.
I have a question,
yes.
Mary Beth.
Go ahead,
I'm
Lauren.
happy for yours.
I'm sorry, I
happy
didn't
for
see
yours
your
to
hand.
go first. I'm happy for yours to go first if you want, but it's actually a very specific question, actually, Eloisa, about there's a few people on here from different lake projects. So I just wondered if you could just say a little bit about the Italian use case on lakes, what it was trying to focus on.
For sure, and I also would like to point out that it was the final with somebody that you introduced to me, the colleague from Eurolakes, and because we selected Italy, and we checked that they have a case study in Italy with the Vico Lake. And so we have meetings with the University of Tuxia to define this. And let me just, I need at least to have on my the visual description, just to not say you. Okay, so the problem that they see in the Vico Lake are related to the fact that is a volcanic lake that is located in Italy, as I said, and they had found some problem regarding to arsenic levels, and that was slight above of the threshold of 10 milligrams per liter. And then also they reported high levels of cyanobacteria, and also the increasing of eutrophication in the lake. So these are the main problems that they have from a water quality perspective, let's say. And then they have also some problems related to animals that are there. They are changing the ecosystem. From one side, there are wild boars that are eating or were eating the grass. And so the farmers started using fertilizers, but of course this is a problem for the lake, and so is also affecting the quality of the water of the lake. And then there is another animal that is the koipu. That is an animal that is eating, that is changing somehow the biodiversity of the lake, the area around the lake, because it wasn't, this kind of animal wasn't in the, let's say, in the original setup of the ecosystem, but they arrive now, and so they are changing, and so is another issue that they have to take into account.
Okay.
But I may also send you this by mail, and we would like also to have your feedback.
So it's linked to a Eurolakes demo site.
Yes, yes.
So, Eloisa, just to clarify, you said koi, so those are fish, koi fish?
No, koipu, I think, which is like a beaver or something like that.
It's like in Italian it's called nuria.
Like a rat, a muskrat
Like
or
a rat,
something.
like a rat, correct, like a rat.
Oh, okay. Koipu. That's a new one for me. But I do know that those wild boars are ravaging Italy. They were commenting on it the last time I was there. My question in the chat was whether or not, like what from your project's perspective, what qualifies as a requirement, or what is recognized as a requirement? Does it have to be in a national action plan or proposed by an agency? Or if somebody just says, oh, from like a consortia, this is what we want, is that enough to qualify as a requirement?
Okay, I think that the requirement that I see, probably because of my background, is related to the technical aspects. Because at the end, the real implementation depends and will depend on the specific type of water, of the specific, because, for example, the case of the lake, we have these wild boars, but they are not in another lake, in another place. So it's a very specific issue. But what will be in common to all the future digital twins will be the architecture, will be the structure that will be beyond the scene.
Okay. Well, thank you so much. We have run out of time. Thank you. So again, let's give a hand or a virtual hand reaction to our speaker today. Thank you so much, Dr. Vargiu for presenting about ideation. And our website under the past presentations will host the link to the video. We do have an upcoming video webinar in December.
Okay.
It will be by Brockman Consult, a 4-person presentation about some of the next generation tools that they have just released for Copernicus products. So we hope to have more information shared, like a title, formal title. It's just now called the Digital Dive right now, but more details about that to be shared. If you are not already receiving notifications about GeoAquaWatch webinars, you can sign up on our website, which is www.geoaquawatch.org. In the lower right-hand corner, you can get all our newsletters and announcements. So thanks again to our speaker, and have
No,
a
thank
wonderful
you
day.
for inviting me. It was a pleasure for
Of
me, and sorry
course.
for the technical issues.
Oh, no problem. Everything worked out great.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thanks, Eloisa. Bye.
Bye.